Hello students, welcome to the class. So in the previous class, we had discussed some set of questions. Now moving to the next set of questions, probably these are the last set of questions of this topic. So here we have the 71st question, which has the highest pH. pH highest means what? It should be more basic, right? So they have given us options CH3COK, potassium acetate, sodium carbonate, ammonium chloride, and sodium nitrate. Okay, so which is having out of this the highest pH? Okay, now see, when we speak about ammonium hydroxide, it is a weak base. It is a weak base. Okay, but HCl, what is HCl? It is a strong acid, correct? It is a strong acid. So when this weak base and strong acid combine in the solution, it will form what? It will form NH4Cl. So I can say NH4Cl is a salt of weak base and strong acid. Weak base and strong acid. So the pH will be what? The pH will be strong acid. So it will be comparatively low. pH will be comparatively low because pH will be slightly acidic because you have taken strong acid. Okay. If you look at NaNO3, sodium nitrate. Sodium nitrate, it is a salt of say NaOH, which is a strong base and HNO3, nitric acid, that is a strong acid, correct? So it is a strong base and strong acid, we'll get NaNO3. Therefore, the pH of this solution will be neutral, that will be 7. Then when you carry out hydrolysis of potassium acetate, it contains what? It contains CH3COOH, which is a weak acid, and KOH, which is a strong base. Correct? Strong base. So it is, I can say it is a salt of weak acid and a strong base. So when base is strong, the pH will be what? It will be alkaline. Alkaline means what? It will be basic in nature. Yes, it will be alkaline. So the pH, I can tell you, it is around 8.8 for CH3COK. Okay. Then if you look at hydrolysis of sodium carbonate, it is formed from strong base NaOH, and so this is strong base, and it is formed from weak acid H2CO3. So this is weak acid. So if you look here, Na2CO3, the dissociation, if we speak here, Na2CO3 in water undergoes hydrolysis to give Na plus ions plus OH minus ions. Yes, I'll balance it by writing 2 here because there is 2, and I'll take 2 here, plus H2CO3 it contains. So this is acid and salt base present in Na2CO3. Therefore, since there are more number of OH minus ions, the pH of this solution is around, or you can say more than 10. So which is having highest pH? It is sodium carbonate, Na2CO3, and understood why. So in NH4Cl, pH is acidic. NaNO3, it is neutral, 7. CH3COK, it is 8.8. And sodium carbonate, it is more than 10. It is more than 10. Yes? Okay. It is more than 10. So that is the correct option. Is that right? Okay. So correct option is sodium carbonate. Moving to the next question. Ionization constant of CH3COOH is 1.7 into 10 raised to minus 5. And concentration of H plus ions is 3.4 into 10 raised to minus 4. Then find out the initial concentration of CH3COOH. See, such good questions are being, we have to understand these questions. So we know that acetic acid is a weak acid. So it dissociates partially to give me CH3COO minus plus H plus ions. Write the dissociation constant, what you get? Ka is equal to concentration of CH3COO minus acetate ions into concentration of H plus, that is protons, divided by concentration of CH3COOH, concentration of CH3COOH. Now I need to find what? Initial concentration of acetic acid. So I will take this here, CH3COOH is equal to Ka. Yes, Ka comes at the bottom, correct? So I'll take CH3. Okay. So CH3COH gives me what? Concentration of CH3COO minus into molar concentration of H plus divided by Ka. Is that right? Take K here. So what is the concentration of CH3CO minus they have given? It is 3.4. H plus ion concentration is 3.4 means what? How many H plus ion concentrations is there? That much only CH3CO minus will be there. Therefore, 3.4 into 10 raised to minus 4 into 3.4 into 10 raised to minus 4. The whole divided by Ka is how much given? It is 1.7 into 10 raised to minus 5. Solve this out. This is minus 8 plus 8, 10 raised to minus 3. When you solve this out, it comes out to 17 ones are 17, 2s are 34. 3, so 2 into 3.4. You will get 6.8 into 10 raised to minus 3 as the answer. Direct question. Is that correct? Yes. So what is the correct option? 6.8 into 10 raised to minus 3. The correct option is option D, 6.8 into 10 raised to minus 3. Yes. Next question. Correct relation between dissociation constants of dibasic acid is. Okay. So Ka1 is equal to Ka2, Ka1 is greater than Ka2, Ka1 is less than Ka2, Ka1 is equal to 1 by Ka2. So what is this Ka1 and Ka2? When we have dibasic acid means what? It is having 2 protons which can be donated. So I will write dibasic acid like this, H2A, correct? So it will dissociate to give me what? It will dissociate to give me Ha minus plus H plus, correct? So this is the dissociation constant of first acid. So I will write it as Ka1, right? Okay. Then Ha minus will further dissociate to give me what? To give me A minus 2 plus H plus. And this is the second dissociation constant. So if you look here in the first step, H plus ion comes from a neutral molecule. So H plus ion is coming from what? From a neutral molecule. Okay. While in the second step, H plus ion is coming from an anion, from negatively charged ion. The presence of this negative charge makes removal of H plus ion difficult. Yes. So I say presence of negative charge makes removal of H plus ion difficult. So when that becomes difficult, I can say Ka1 is greater than Ka2. Is that right? So Ka1, the dissociation constant or equilibrium constant of first reaction is more than second step reaction of the reaction. So Ka1 is more than Ka2. Is that right? Next question. Which statement is wrong about pH and H plus ion concentration? pH of neutral water is not 0. Adding one normal solution of CH3COH and one normal solution of NaOH, pH will be 7. H plus ion concentration of dilute and hot H2SO4 is more than concentrated and cold H2SO4. Mixing solution of CH3COH and HCl, pH will be less than 7. First option, pH of neutral water is not 0 because we know that pH is what? It is 7, neutral water. Neutral pH is 7, correct? Second option, adding one normal or solution of CH3COH and one normal solution of NaOH, pH will be 7. See here, after mixing, yes, after mixing one normal solution of CH3COOH. What is CH3COH? It is weak acid. And one normal solution of NaOH. What is NaOH? Strong base. Resulting solution will have what? It will have more OH minus ions. So pH will be what? More than 7. pH will be higher than 7. So this is the wrong statement about pH. H plus ion concentration of dilute and hot H2SO4 is more than concentrated and cold H2SO4. Yes, that is correct. Mixing the solution of CH3COH and HCl, pH will be less than 7. Yes, because this is weak acid and this is strong acid. So when strong acid is there, there will be more number of H plus ion concentrations. Therefore, pH will fall below 7. It becomes more acidic. So which is the wrong statement? It is the second statement which is wrong. Correct? Next one. The concentration of H plus and concentration of OH minus ions in a 0.1 aqueous solution of 2% ionized weak acid is ionic product of water is given. Okay, let us see how we can solve it out. So what they have said, concentration of H plus ion and OH minus ion concentration of 0.1 aqueous solution. So H plus ion concentration is what? It is equal to C alpha. What is C? C is concentration 0.1. And alpha is what given? It is given 2%. So what I should do? 2 divided by 100. This comes out to what? 0.02. Please remember this. Convert, if percentage is given, convert it to this value divided by 100 into 0.2. Therefore, what I get? 2 into 10 raised to minus 3 molarity. Yes. So degree of dissociation is 2%. 2% means 2 by 100. Therefore, OH minus ion concentration will be what? We know that it is ionic product of water is 10 raised to minus 14. 1 into 10 raised to minus 14 divided by how much I've got H plus ion concentration? 10 raised to minus 3. Because I know this formula, H plus ion concentration into OH minus ion concentration is equal to Kw. Therefore, OH minus ion concentration is equal to what? Kw divided by H plus ion concentration. Kw is 10 raised to minus 14 divided by H plus ion concentration is 2 into 10 raised to minus 3. Solve it out. 1 by 2 is 0.5. 0.5 into 10 raised to minus 14 and plus 3 becomes what? 10 raised to minus 11. Or I can write it as shifting decimal point to the right. 5 into 10 raised to minus 12 molarity. Yes. So it is 5 into 10 raised to minus 12 molarity. So which is the correct option? H plus ion concentration and OH minus. So H plus ion concentration I have got how much? 2 into 10 raised to minus 3. So A is there. 2 into 10 raised to minus 3. Anywhere else? No. And OH minus ion concentration 5 into 10 raised to minus 12. So option A is the correct option. Yes, option A is the correct option. Next question. The hydride ion concentration. The hydride ion H minus is stronger base than its hydroxide ion OH minus. Which of the following reaction will occur if a sodium hydride, that is NaH, is dissolved in the water? See, hydride ion is a stronger base than OH minus ion. When you dissolve NaH, which reaction will occur? So let us see reaction itself here. NaH, sodium hydride, when you dissolve it in water, it will form what? It will form NaOH plus liberate hydrogen gas. Or I can write it like this. In NaOH, what is the hydride ion? It is H minus, correct? From this. Plus H2O will give me what? It will give me NaOH means what? OH minus ion plus H2. So which is the correct option? H minus plus H2O gives OH minus plus H2. So option C is the correct option. Understood? So how it dissociates, we must be knowing. That's it. Once you know how it dissociates, we can get them in first reaction. I wrote it in molecular form. The second reaction was in ionic form because here they have asked ionic form. Correct? Okay. The ionic product of water at 25 degrees Celsius is 10 raised to minus 14. Its ionic product at 90 degrees Celsius will be. We know that ionic product of water. What is ionic product of water? It is the product of molar concentrations of H plus ions and OH minus ions in the solution. And when we talk about neutral solution, H plus ion concentration and OH minus ion concentration is equal. So ionic product of water is 10 raised to minus 14. And in H plus, since they are equal, it is H plus ion concentration is 10 raised to minus 7. OH minus ion concentration is 10 raised to minus 7. Okay. Here they have said at 25 degrees Celsius, the ionic product of water is 10 raised to minus 14. Yes, we know this. Kw at 25 degrees Celsius, Kw is 1 into 10 raised to minus 14. Then what is its value at 90 degrees Celsius? Now they have increased the temperature, right? We know that at high temperature, the value of ionic product of water also increases. Yes, ionic product value increases as temperature increases. So what it will be? It will be more. Yes, it will be more. So 10 raised to minus 14, no. 10 raised to minus 16 is what? It is less. 10 raised to minus 20 is also less. More means what? It is 10 raised to minus 12. Understood? So it will increase. The ionic product of water will increase. That means this negative value should decrease. Yes or no? The negative value should decrease. So option D is the correct option. Is that understood? Next question. If alpha is the dissociation constant, then the total number of moles for the reaction 2HI gives H2 plus I2 will be. So alpha is what they have said. Alpha is degree of dissociation. So I will write here. Reaction is given 2HI gives me H2 plus I2. Yes. So here initially if I want to speak initially, how many moles are there? There are 2 moles here. And this is 0 because reaction has not started only. At equilibrium, alpha has got converted, correct? So alpha, here how much it will be? 2 minus 2 alpha, correct? If this is C minus C alpha we get, like that. So total number of moles will be equal to what? This can I write it as 2 into 1 minus alpha plus alpha. So that will be equal to what? So 2 into 1 minus alpha plus 2 alpha. Yes, the option is not here. So 2 minus 2 alpha plus 2 alpha. So minus 2 alpha plus 2 alpha cancels. What remains? It is option C. That is 2. So alpha, the total number of moles for the reaction will be 2. Is that understood? Yes? Okay. So it is correct option is option C, that is 2. Next, the pH value of N by 10, N stands for normality, NaOH solution is. So they have asked us pH of N by 10 value. Okay. Which compound they have taken? NaOH. And we know that NaOH is what? It is a strong base. Okay. Since NaOH is a strong base, it completely ionizes. Yes. It ionizes completely. Correct or no? It ionizes completely. Thus, the hydroxyl ion concentration is equal to what? It is equal to that of the base itself. How much concentration of NaOH you have taken, that much of OH minus ions you'll get. Yes or no? So it is equal to the concentration of NaOH since it is a strong base. Correct? We know that the concentration of OH minus ions, in how much they have said? N by 10 of NaOH is 0.1. Yes, N by 10 means what? 1 by 10, it is 0.1. That is equal to 10 raised to minus 1. Therefore, value of H3O plus ions will be how much? Similarly, we have to do, we know that ionic product of water. I can write it like this also, H plus into OH minus, rather than writing like that. I can write H3O plus into OH minus is equal to Kw. Therefore, H3O plus is equal to how much? Kw divided by OH minus ion concentration. So Kw is how much? 10 raised to minus 14 divided by 10 raised to minus 1. That comes to what? 10 raised to minus 13. So this is value of H plus ion concentration. Now I want to calculate pH. It is what? Negative log of H3O plus ion concentration, or I had told you, do you remember how to find pH? Negative log of H plus ion, or I can say H3O plus ion concentration is what? Minus log of pH. Correct? So pH we will get if you know the H3O plus ion concentration. Correct? Yes or no? Therefore, I can say either write it like this, minus log of 10 raised to minus 13, or solve it out, minus minus becomes plus, log 13 plus log 10. 13 into log 10. So how much you get? You will get answer 13. 10 raised to how much is there? If there is 1 into, okay. If it is 1 here, 10 raised to how much? That will be itself the pH. That will be the pH. And if you want to find pOH, you know that pOH, they have not asked pOH, but still I'm saying, will be equal to what? 14 minus pH. So 14 minus 13 is what? 1. Yes? Is that understood? So pH is 13. pH of the N by 10 of NaOH is how much? It is 13. Option B is the correct option. The pH value of 10 molar solution of HCl is 10 molar solution of HCl. A similar question to that of above one. But let us see how we can solve it out. Now they have said HCl, and we know that HCl is what? It is a strong acid. So it is, since it is strong acid, it ionizes completely, correct? It ionizes completely. Therefore, the H3O plus ion concentration is nothing but what? Concentration of HCl. It is equal to the concentration of HCl itself. That is, can I say H3O plus is equal to HCl concentration, and they have said 10 molar, 10 molarity. Yes, therefore find the pH. Negative log of H3O plus ion concentration minus log of 10. And what is log of 10? It is minus, keep it as it is, minus 1. So pH is what? It is minus 1. That means it is what? It is less than 0. Yes or no? So let us see which value holds good. Equal to 1, equal to 2, no. Less than 0. Yes, it is less than 0. That is, it is minus 1. Yes? Okay. Next question. At 80 degrees Celsius, distilled water has H3O plus ion concentration equal to 1.1 into 10 raised to minus 6 moles per liter. The value of Kw at this temperature will be Kw, ionic product of water. Now see here, we know that H plus ion concentration, or I can write it as H3O plus ion concentration, is equal to OH minus ion concentration. Yes. And they have given it how much? 10 raised to minus 6 moles per liter means what? It is molarity. Therefore, find Kw. H3O plus into OH minus, and that is equal to what? 1 into 10 raised to minus 6 into 1 into 10 raised to minus 6. This comes out to what? 1 into 10 raised to minus 12. Kw of water is 1 into 10 raised to minus 12. Cleared? Simple. So 1 into 10 raised to minus 12. Option A is the correct option. Is that right? Next question. 0.1 molar solution of which of these substances will act basic? Sodium borate, ammonium chloride, calcium nitrate, sodium sulfate. Okay. So let us consider here. The first option given is what? Sodium borate. Borate. Okay. Then second option is ammonium chloride. Correct? So it is ammonium chloride. Then the third option is calcium nitrate. And last option is sodium sulfate. Yes, sodium sulfate. Okay. So sodium borate. What is sodium borate? Sodium borate is formed from what? It is formed from sodium hydroxide and boric oxide. Correct? So sodium hydroxide and boric acid. Boric acid is BOH thrice. Yes. So sodium hydroxide is there and boric acid is there. Okay. Then next is ammonium chloride, NH4Cl and HCl, calcium nitrate, calcium hydroxide and HNO3, nitric acid. Sodium sulfate. Sodium sulfate is what? Sodium sulfate is formed from sodium hydroxide. Okay, here boric acid I said. So it is H3BO3, boric acid. Okay. Then sodium hydroxide and H2SO4. So if you observe all the reactions, if you observe all the compounds, here sodium borate, it is a salt from strong, I'll take it different, strong base and weak acid. Yes, whereas this, it is ammonium chloride, it is formed from ammonium hydroxide, that is what? Weak base and strong acid. Okay, this is what? Weak base, and this is also strong acid, and this is strong base and strong acid. Yes, strong base, strong acid, they are neutral. Weak base, strong acid, acidic. Weak base, strong acid, acidic. But sodium borate, it is formed from strong base and weak acid. Therefore, it will be what? It will be basic. So question is what? 0.1. All of them, they are 0.1 molar only. 0.1 molar, 0.1 molar and 0.1 molar. So 0.1 molar solution of any of these substances will give me these acids and bases because all are salts. When you look at sodium borate, it is only salt where it is having strong base and weak acid. So since there is strong base, OH minus ion concentrations will be more. Therefore, it becomes basic in nature. It becomes basic in nature. So option A is the correct option. Correct? Okay. The compound whose water solution has highest pH is. Water solution means what? Aqueous solution has got highest pH. Okay. NaCl is a salt of NaOH and what? And HCl. Correct? NaHCO3, sodium bicarbonate. It is a salt of sodium hydroxide and H2CO3. Na2CO3, it is a salt of NaOH and H2CO3. Here twice we did. NH4Cl, it is the salt of NH4OH plus HCl. So if you see here, NH4Cl and NaHCO3, options B and option D, these are what? These are acidic in nature. Both are acidic in nature. Yes. Na2CO3 is basic in nature. Thus it will have, and this is what? NaCl, it is also acidic. So NH4Cl and NaHCO3 both are acidic. Whereas NaCl, it is having both strong acid, strong base. So it will be neutral. Whereas Na2CO3, it is strong base. Therefore, it will have basic and therefore pH will be highest for Na2CO3. The pH will be highest for Na2CO3. Correct? So it is, which is the correct option? It is Na2CO3. Which will make basic buffer? So question is on buffers. 100 ml of 0.1 molar HCl, 100 ml of 0.1 molar NaOH, 50 ml of 0.1 molar NaOH, 25 ml of 0.1 molar CH3COH. 100 ml of 0.1 molar CH3COH, 100 molar of 0.1 molar NaOH, 100 ml of 0.1 molar HCl and 200 ml of 0.1 molar NH4OH. Now see here, when we talk about basic buffers, okay, acid-base titrations we need to consider. So acid-base titrations. So HCl plus NaOH gives me what? Okay, HCl plus, let me take NH4OH, strong acid and a weak base. I will get NH4Cl. Okay. Solution. Therefore, here if you see, HCl becomes, here 20 molar of millimoles of HCl NH4OH have taken, 10 millimoles of HCl have taken. Therefore, HCl becomes what? HCl becomes limiting agent. So solution of NH4OH, which is a weak base, and NH4Cl, which is a strong salt of strong acid and weak base, it will be a basic buffer. So correct option is what? Option D. Option D is the correct option. That is 100 ml of 0.1 molar HCl and 200 ml of 0.1 molar NH4OH. Next question. Which of the following pairs is not an acidic buffer? What is an acidic buffer? Acidic buffer is a mixture of what? Weak acid and its a salt. It's a salt of strong base. Strong base. Correct? So weak acid, where this is weak acid. Okay, it's a salt of strong base. Yes, this is acidic buffer. Weak acid, it's a salt of strong base. Yes, this is acidic buffer. Weak acid, H3PO4, it's a salt of strong acid. Yes, strong base, correct. HClO4 itself is a strong acid. But we know that acidic buffer means it should have weak acid. But HClO4 is what? Strong acid. Therefore, it is not an example for acidic buffer. So option D is not the example for acidic buffer. Correct? The dissociation constant, next question, of a weak acid is 1 into 10 raised to minus 4. In order to prepare a buffer solution with pH 5, the salt concentration of salt to concentration of acid ratio should be. It is Henderson's equation. Correct? Okay. Let us solve and see then. According to Henderson's equation, we know that pH is equal to what? It is equal to pKa plus log ratio of molar concentration of salt to molar concentration of acid. Correct? Now pH is being given. pH, how much it is given? It is given 5 is equal to. What is pK? pK is nothing but minus log of K. Correct? Plus log concentration of salt to concentration of acid. Yes, because we know pK is minus log of K. 5 is equal to minus log. What is value of K given? It is 1 into 10 raised to minus 4. And that comes out to 4 plus log salt concentration to acid concentration. Yes. So this comes out to 5 equal to minus 4. 5 equal to 4. Minus minus gets cancelled. Plus 4 plus log concentration of a salt to concentration of acid. Yes. 5 minus 4 this side you take. 5 minus 4 is how much? 1. Therefore 1 is equal to log concentration of salt to concentration of acid. Yes. Or take log this side. What we get? Concentration of salt to concentration of acid is equal to 10. Yes, it is equal to 10. Therefore, what is the ratio? The ratio is 10 is to 1. 10 divided by 1. So the ratio is what? 10 is to 1. Is that understood? Yes, Henderson's equation we have to use and solve. So the ratio is what? It is 10 is to 1. Option B is the correct option. Next question. Buffer solutions have constant acidity and alkalinity because. Why do they have constant acidity and alkalinity? These give unionized acid or base on reaction with added acid or alkali. Option B. Acids and alkalis in these solutions are shielded from attack by other ions. Option C. They have large excess of H plus and OH minus ions. Option D. They have fixed value of pH. The correct option Here, why do they have constant acidity and constant alkalinity? Because buffer solutions are weak acids or weak bases, and they are salts of strong base or strong acid, correct? So they give unionized acid or base on reaction with added acid or alkali. That's the reason they have constant acidity and alkalinity. So option A is the correct option. Yes, option A is the correct option. Next question. A buffer solution is prepared in which the concentration of ammonia NH3 is 0.30 molarity and the concentration of NH4 plus is 0.20 molarity. If the equilibrium constant Kb for NH3 equals 1.8 into 10 raised to minus 5, what is the pH of the solution? And log 2.7 is 0.43, they have already given. Okay, let us try to solve it out. So they have given us what? Concentration of NH3. The concentration of NH3 is how much given? It is 0.30 molarity. Yes. What is the Kb? Kb is how much? Dissociation constant. How much it is given? Dissociation constant is given as 1.8 into 10 raised to minus 5. 10 raised to minus 5. Correct? Okay. And NH4 plus ion concentration. NH4 plus ion concentration is how much? 0.2 molarity. 0.20 molarity. What is pKb? If Kb is given as so much, what is pKb? It is minus log of Kb. Therefore, minus log of 1.8 into 10 raised to minus 5. Correct? Yes. Solve it out. You will get the answer 4.74. 4.74. Okay. So this is pKb value. pOH, how do we find? We know that it is equal to pKb plus log concentration of salt to the concentration of base. Concentration of base. So that is equal to pKb equal to, shall I solve it here? It is 4.74 pKb value plus log concentration of salt. How much they have given? They have given it 0.2 divided by concentration of base. It is 0.3. Yes. So 0.2 by 0.3, solve it out and take the pH. You will get log, you take pOH is equal to 14 minus 4. Here the answer what you get is 4.56. Yes, 4.56. So this is pOH. pOH is how much? 4.56. So once we get to know pOH, calculating pH is not difficult because it is what? 14 minus pOH. So 14 minus 4.56 comes out how much? It comes out to 9.44. Understood? Ammonia concentration is given, NH4 plus is given. So this is salt concentration, salt NH4Cl, and this is base. Therefore, pKb you calculate, pOH is equal to pKb plus log concentration of salt to the concentration of base. You will get answer for pOH. When you get pOH, pH is not difficult. It is 14 minus pOH value, and that is how much? 9.44. So option B is the correct option. Option B is the correct option. Yes, next question. In the buffer solution containing equal concentration of B minus and HB, the Kb for B minus is 10 raised to minus 10. The pH of the buffer solution is, okay, they have given us HB. Okay, see, just now we have seen, we know that pOH is equal to what? It is equal to pKb plus log concentration of salt, that is B minus, upon concentration of base. Yes. And they have already given that B minus is equal to what? It is HB. This is already given. Therefore, can I write it? This is same. So it is log 1. Therefore, can I write pOH is equal to pKb, and therefore POH is equal to what? It is equal to 10. Yes, because here they have said 10 raised to minus 10 kb. When you take pKb, it will come out to 10. Then find the pH. pH will be 14 minus 10, and that comes out to what? It comes out to 4. So option 4 is the correct option. Cleared? Yes. Next question. Which of the following pairs constitute a buffer? HCl and KCl, HNO2 and NaNO2, NaOH and NaCl, HNO3 and NH4NO3. What constitutes a buffer? It should be weak acid plus salt of its salt of, I'm sorry. And it's a salt of strong base, or it should be weak base and it's a salt of strong acid. Correct. So HCl is strong acid, does not come. NaOH is strong base, does not come. So these two options are ruled out. HNO3 is a strong acid, does not come. If you look at HNO2, nitrous acid, HNO2 is what? It is nitrous acid. Nitrous acid is a weak acid. Yes. And the salt from, it's a salt from strong base. That means when HNO2 combines with strong base NaOH, it should form a salt. The salt formed is NaNO2 plus H2O. Therefore, NaNO2 is, it's a salt of strong base. Therefore, this is what? This constitutes a buffer. It constitutes a buffer. So that is the correct option. Yes. Next question. The rapid change of pH near the stoichiometric point of an acid-base titration is the basis of indicator detection. pH of the solution is related to the ratio of concentrations of conjugate acid HLN and base Ln minus, In minus, forms the indicator by the expression. Okay, let us solve it out properly and see what expression it forms. Let us consider formation of a salt of weak acid and strong base. Okay, so I'll write it here. In minus plus H2O partial dissociation gives me HIN plus OH minus. Correct. This hydrolysis constant, how do I write it? This is hydrolysis. So I will write concentration of HIN into concentration of OH minus divided by concentration of In minus. Yes, hydrolysis. Correct. So let me call this as equation 1. Cleared? Okay. Now, other equations present in the solution. When they gave us the solutions, what are the other equations? Let us see what all happens here. One expectation is that HIN, it may dissociate to give me H plus plus In minus. Yes. Or H2O may dissociate to give me H plus plus OH minus. Yes. So if you write KIN will be equal to what? It will be equal to molar concentration of H plus into molar concentration of In minus divided by molar concentration of HIN. Yes. Call this as equation 2. Is that clear? Okay. Let me take it like this here. Okay, fine. Further, you know that what is Kw? Ionic product of water, H plus ion concentration into OH minus ion concentration. Let me call this equation as equation 3. Now what you do from equations 2nd and 3rd, from equation second and third. I can write Kw divided by Kin is equal to what? This goes to the numerator. It becomes Hin into OH minus. H plus gets cancelled, divided by In minus. This is what I get. Let me call this as equation 4. Understanding? From equations 2 and 3, I got this. Yes? Okay. OH minus ion concentration is what? OH minus ion concentration is nothing but Kw upon Kin, and solve it out, you will get In minus upon Hin. Yes. So take log and negative log you take. So if I write here log of OH minus ion concentration is equal to log of Kw minus, it is in the denominator, log of Kin plus log of In minus by Hin. Is that right? In minus by Hin. Okay. So I'll write it once again here. Log of OH minus is equal to log of Kw minus log of Kin plus log In minus by Hin. Is that right? Yes. So minus, this is minus. If it be, I would have written POH. Since it is, there is no minus, I'll write minus of POH. POH is equal to, there is also no minus, minus PKW. And here minus Kin is there. So plus PKIN plus log concentration of In minus to the concentration of Hin. Correct? So take PKW this side. PKW is equal to POH, or I'll write PKW minus POH is equal to PKIN plus log In minus divided by HIN. Correct? In minus divided by HIN. What is PKW minus POH? It is nothing but pH. So pH will be equal to what? PKIN plus log concentration of In minus divided by HIN. I get this? Yes. Take log, last one, log of In minus divided by HIN is equal to what? It is equal to, taking log that side, yes, or PKN, if you take this side, it will be pH minus PKIN. Understood what we got here? So let us consider this reaction. I'll get KH. Call this as equation 1. Other equations, what are happening in the reaction? So it is HIN dissociation to give this, H2O dissociating to give this. So KIN, if I want to write KIN minus, it is HIN into HIN minus divided by of the salt here. So divided by HIN. And KW is what? Ionic product of water, H plus into OH minus ion concentration. 2 and 3, KW upon KIN will give me what? It will give me so and so. So from this entirely, if I want OH minus ion concentration, I will find OH minus ion concentration will be equal to what? KW upon KH will remain as it is, KIN will remain as it is, IN minus will go up and HIN will come down. Take log of it, and then so you will get log OH minus is equal to log KW minus log KIN plus log of concentration of ion minus upon concentration of HIN. Then if it would be minus log of OH, I would have written POH. Since it is plus log, I will write minus POH. Again, plus log KW minus PKW. Keep this as it is. This is minus log KIN. So PKIN plus I'll write, plus log this I'll keep it. Take my PKW to this side, PKW minus POH is so and so. PKW minus POH is what? It is pH, because I know pH plus POH is equal to what? PKW. Yes, therefore it is pH. That is equal to so much. So if I want to find log of this, it will be pH minus PKIN. Yes, pH minus pKin, because my examples, my options has got that perfect this. So is it, what is the correct option? Log in minus upon log HIN is equal to pK. No, which is the correct option? It is option D. Log in minus concentration upon concentration of HIN is equal to pH minus pKin. pH minus pKin. Yes. Next question. Solution of 0.1 normal NH4OH and 0.1 normal NH4Cl has pH 9.25. Find out pKb of NH4OH. See what solution they have given. Yes, they have said solution of NH4OH. NH4OH, how much they have given? 0.1 normal, and NH4Cl, it is 0.1 normal again. Yes, and its pH is being given. Its pH is what? 9.25. It is example for basic buffer. You can see here, this is a weak base and this is its salt of strong acid. Salt of strong acid, correct? So it is a basic buffer and pH is 9.5. So it is a basic buffer according to Henderson's equation. According to Henderson equation, what we can say, according to Henderson equation, the pH of basic buffer, the pH of basic buffer is given by pH is equal to 14 minus pKb, 14 minus pKb minus log concentration of salt to the concentration of basic buffer. Okay, so I can write here pKb is equal to, I'll take Kb here, pKb is equal to 14 minus pH minus log concentration of salt to the concentration of base. Correct? Therefore, pKb is equal to what? 14 minus, what is the pH? 9.25 minus log, what is the concentration of salt? Salt is NH4Cl 0.1 upon concentration of base 0.1. So it cancels and comes out 1. It is 0. Therefore, 14 minus 9.5. So pKb is equal to what? 14 minus 9.25. Therefore, pKb is equal to how much? We will get 4.75. Correct? 4.75. So pKb of base, correct? pKb of NH4OH is how much? 4.75. So what is the correct option? 4.75. Yes, option B is the correct option. Option B is the correct option. Next question. A physician wishes to prepare a buffer solution at pH 3.85 that efficiently resists the changes in the pH. So it is a buffer solution, yet contains only small concentration of the buffering agent. Which of the following weak acids together with its sodium salt would be best for the use? So options given are 2.5 dihydroxybenzoic acid, pK value is 2.97, acetoacetic acid, pK value is 3.58, chlorobenzoic acid, pK value is 3.98, and p-chlorocinamic acid, pK value is 4.41. Now see, when we talk about using a buffer solution, pH of acidic buffer, yes, it is given by Henderson's equation. Yes, as given by which equation? Henderson's equation. We have seen this. Just now we had seen for basic buffer. Now this is for acidic buffer. What is the pH? The pH is given as pH is equal to pKa plus log concentration of salt, or you can say salt concentration upon acid concentration. Yes, and they have said its buffer capacity. Yes, it's a buffer capacity. We know, we have seen what do we mean by buffer capacity is equal to what? pKa, and that is plus or minus 1. Okay. So since the buffer solution is more effective, according to this, what we may understand, it means the buffer solution, yes, the buffer solution is more effective. It is more effective in pH range where pKa is plus or minus 1. Therefore, the weak acid having pKa around 3.58 together in our options, I'm saying 3.58 together with its what? With its sodium salt is chosen, has to be chosen. Yes. Why? Since the buffer solution is more effective in the pH range, pK plus or minus 1. Yes. Therefore, the weak acid having the range of, which is given 3.58 together with its sodium salt has to be chosen. Yes. Therefore, which is having a 3.58? It is acetic acid. Its pKa value is 3.58. 3.58. Is that understood? Acetoacetic acid is being used. Yes. Next question. So here, which is the correct option? It is option B, acetoacetic acid, whose pKa is 3.58. Moving to the next question. The pH of blood does not appreciably change by a small addition of an acid or a base because the blood can be easily coagulated, contains iron as a part of molecule, is a body fluid, contains serum protein which acts as a buffer. The reason why the pH of the blood, yes, if you see what is the pH of the blood, tell me. The pH of blood is, yes, it is 7.4. We have discussed this. It is maintained constant. Yes, it is maintained constant. How it is maintained constant? It is by the buffer solution. It is maintained constant by buffer solution. Present where? Present in the blood itself. Present in blood itself, not anywhere outside. Yes, present in blood itself. And which is that buffer solution? And we know that what is the work of buffer solution? Buffer solutions resist what? Resist change in pH. Change in pH upon addition of an acid or a base. Yes. Therefore, pH of blood remains constant. The reason is what? Because it contains the serum protein which acts as buffer. That is present in the blood itself. Which is present in the blood itself. Yes. Next question. pH of a saturated solution of calcium hydroxide is 9. The solubility product of KSP of calcium hydroxide. Okay. This is the question on solubility product. Okay. Now see, pH of a saturated solution. pH of saturated solution of calcium hydroxide. Saturated solution of calcium hydroxide is how much given? 9. Okay. Therefore, pOH of saturated solution, because calcium hydroxide is a base, right? So pH is given. What will be the pOH of saturated solution of calcium hydroxide? We know that pH plus pOH. Yes, we know this equation. pH plus pOH is equal to 14. Yes, therefore, can I calculate the pOH? It is 14 minus 9 and that is equal to 5. That is equal to 5, correct? So if pOH is 5, if pOH is equal to 5, then what will be H plus ion concentration, OH minus ion concentration? The OH minus ion concentration will be 10 raised to minus 5, correct? It will be 10 raised to minus 5. How does calcium hydroxide dissociate? Calcium hydroxide, it dissociates to give what? It dissociates to give Ca plus 2 ions plus OH minus ions. Correct? It gives us like this. If this S is the solubility of calcium ions, then how much will be for OH minus? It will be S and coefficient is 2 here. Correct? How much is calcium ions given? Is it given? No, it is not given. So 10 raised to minus 5 is OH minus ions. Correct? 10 raised to minus 5 is 2S. Then what is S? Half of 10 raised to minus 5. So half into 10 raised to minus 5. Understood? Now find out the KSP. How do we find out KSP? Solubility product is equal to what? Molar concentrations product of molar concentration of the product ions, OH minus raised to 2. Yes. So what is calcium ions? It is 1 by 2 into 10 raised to minus 5. Yes. Into OH minus ion is how much? 10 raised to minus 5 the whole square. So solve it out. 1 by 2 is nothing but 0.5 into 10. 5 2s are 10 minus 10 minus 5 becomes what? 10 raised to minus 15. So what is the correct option? KSP is equal to 0.5 into 10 raised to minus 15. 0.5 into 10 raised to minus 15. Understood? So pH is given of calcium hydroxide, and we know that calcium hydroxide is a base. So pH is 9, then pOH will be what? 14 minus 9. If pOH is 5, then OH minus ion concentration will be 10 raised to minus 5. Dissociation, if S is what? The solubility of calcium ions, it will be same for OH minus S, and 2 becomes the coefficient. So it is 2S. We know that for OH minus ion concentration, 10 raised to minus 5. So 2S is 10 raised to minus 5. Therefore, S is what? Half of 10 raised to minus 5. I have taken this KSP. I know how to write. So accordingly, substitute the values. Answer will come 0.5 into 10 raised to minus 15. So which is the correct option? 0.5 into 10 raised to minus 15 is the correct option. So option B is the correct option. So we have one more set of questions. I'll be discussing them in our next class. Hope you have followed all these questions. The last set of questions are based on solubility product and remaining part of the chapter. Hope you have understood all the concepts or questions what are being explained now. Please practice so that the last set of questions becomes easy. For now,